Okay, so for the graphs for 15, we'll start with A. And 4 to the negative x, I'm going to rewrite that as 1/4 to the x so that I have a positive exponent. So the asymptote is at y equals 0. And a key point, if we plug in 0, we're going to get 1. And then because it's 1/4, that's exponential decay. So let's see, we have our asymptote. This is our y-intercept. Domain is all reals. Range is y is greater than 0. And it is decreasing. And now for B, our asymptote is at y equals 3 because of the plus 3. If we plug in 0, that's going to be 4 to the 0 plus 3. 1 plus 3 is 4. The graph is increasing because the base is 4. Domain, x is all reals, and the range, y is greater than 3. Now for C, our horizontal asymptote is at y equals 0. When we plug in 0, we're going to get 1. The base is 2/3, which is less than 1, so it's decreasing or exponential decay. The domain, x is all reals, and the range, y is greater than 0. Now for D, our horizontal asymptote is at y equals 0. Our key point, when you plug in 0, will get us 1. And now, because E is a base of 2.7, but has a negative exponent, instead of being growth, it's a decay. So it's decreasing. Domain, x is all reals. Range, y is greater than 0. And lastly, for E, our horizontal asymptote is at y equals 2. Instead of plugging in 0 for the key point, we're going to plug in 1 to get a nice point to graph because that's going to make the exponent 0. So that's 3 plus 2 is 5. And the base is E, so it's increasing. And for our y-intercept, we're going to plug in 0 for x. So that is 3 e to the negative 1 plus 2. We can rewrite that as 3 divided by e plus 2, and it's a no calculator question, so this is the exact value of our y-intercept. Domain, x is all reals. Range, y is greater than 2. The next two problems are calculator problems, 16 and 17. So they are in the calculator video. So is 18, 19, 20, and 21. So now moving on to 22. To rewrite the log in exponential form, we can do the Roman numeral 9 pattern. So if your log is on the left, like A is, the base, when there is no base written, it's the 10. So if we draw the Roman numeral 9, that shows us that it's 10 to the negative fourth equals 1 over 10,000. We can do the same thing for b. So it's going to be 6 to the x equals 216. For c, 8 to the x equals 5. And for d, when it's the ln, that's the log base e, so e to the m equals 7. We can use the same thing for 23. So for example, for a, the exponential expression has to be on the left, so now that gives us log base 32 of 16 equals 4/5. For b, log base e of 2 equals m, but we don't leave log base e. We have to rewrite that as ln of 2 equals m. And then for c, that's going to be log base 10, which we don't write, of 100,000 equals 5. And for 24, to evaluate, you can change it to an exponential form, or for a, we can just think to ourselves 3 to what power is 81, and that's 4. And then for b, 23 to what power is 1. For c, 10 as the base to what power is 100. Now for d, this one's a little bit harder to do in our heads. Log base 9 of 27. We can say, okay, that equals what? I'm going to use w for what. So 9 to what power is 27? Well, neither are the same base, but if we can change both bases to be 3, we can then set the exponents equal and solve. So log base 9 of 27 is 3 over 2. Do the same thing for e. 16 to what power is 8? We can make both of those a base of 2. So then 4w equals 3. So log base 16 of 8 is 3/4. And then lastly for d, 10 to what power is 1/10? Well, the 1/10 we can change and make that 10 to the negative 1. So we get that this evaluates to negative 1. Okay, so for 25, the key point here is if the bases are the same, then the expression simplifies to the term that's left, which is x. X. Now, for e, 5 and 125 aren't the same base, but we can make them the same base by changing 125 into 5 to the third. So now that we have both the bases of 5, the answer is 3x. We can do something similar with f. That's log base 10. 100 is 10 squared. So this simplifies to 2x. Now for 26, a log and an exponential are inverse functions. So the answer to A is the relationship between f of x and g of x is that f of x and g of x are inverse functions. For B, well, the graphs of any inverse functions are reflected. One graph is the reflection of the other about the line y equals x. Okay, so now for 27, to graph the log equations, for 27a, we're going to have a vertical asymptote at x equals 0. And we're going to plug in 1 to get a key point. So log base 10 of 1 is 0, minus 2 is negative 2. Because the base of log is 10, the graph is increasing. So the asymptote is x equals 0, domain x is greater than 0, range y is all reals, and it's increasing. Now for B, because there's parentheses around the x minus 2, the whole argument is x minus 2. So our asymptote is at x equals 2, what makes the argument 0. If we plug in 3, we're going to get 0 as our key point. It's increasing because ln is a base of e, which is more than 1. The asymptote is x equals 2, domain x is greater than 2, range y is all reals. Okay, so now we have 28, solving without the calculator. For A, if we can make the bases on both sides be the same, we can equate the exponents. So I'm going to rewrite 4 as 2 squared. So now I have 2x equals 5 from the exponents, so x is 5 over 2. For B, we have to first divide by the coefficient of 2. Now we can make both sides the same base. I can equate my exponents, and x is 12. For C, because the base is e to start, we can't change e and 9 to be the same base. So instead we can change it to log form. So the ln of 9 is x. We're going to do similar step for D. We can't make 10 and 40 the same base, so we can change it to log. Log base 10 of 40 is x. Now for E, we can make the bases the same. Set the exponents equal, and we get 3 over 2. For F, now that we start with a logarithm with the log f the ln, we can change it to exponential form. So e to the third is x. We're going to do the same thing with G. Two to the eighth is x. We can multiply out 2 to the eighth. That's 256. So either answer is appropriate for G. For H, before we can change it to exponential form, we have to divide both sides by 3. Now it's 2 to the fifth is x, and that's 32. Okay, for I, we can change it to exponential form, and we can square root both sides, get x is 8. We typically would say plus or minus 8 when you square root both sides to solve. But because x is the base of a logarithm, we never have a negative base, so our answer is only positive 8. And now for J, we're going to change that to exponential form. Subtract the 9. So we get that 7 is x. And then for K, we have to first start by dividing by 20. So 5 over 20 reduces to 1/4. We can make the bases the same. This is going to be 2 to the negative 1. And 4 is 2 squared, so that's 2 to the negative 2. So we get negative x over 3 is negative 2. Negative x is negative 6, so x is 6. And last but not least for L, we can make both bases 2. When you have an exponent to an exponent, you multiply the exponents. We're going to move all the x's to one side, all the numbers to the other. So negative 9/4 is x. Number 29 is done in the calculator video, since that's a calculator problem. And now for 30, when we're given 2 points and we have to write an exponential equation, the y-intercept, or when x is 0, will always be your a value. So now we have y equals 5 times b to the x. B, if I prefer to see my points in a vertical table. B is the value you multiply by to move from one point consecutively to the next point. So 5 times 3 is 15. So our answer is 5 times 3 to the x. Now for B, I'm going to do a little bit more work. We have to multiply by b and then by b again. So 20 times b squared will get us 500. We're going to divide by 20. So b squared is 25. So b is 5. Now we have to use that to go backwards. So instead of multiplying by 5 to go forwards in the x values, we're going to multiply by 1/5 to go backwards, and we get that our a value then is 4. So the equation is y equals 4 times 5 to the x. So now 31 is done in the calculator video, since that's a calculator problem. And now for 32, if we compare the way the data is changing in a table, we'll be able to decide which model to use. So for A, I noticed that the y values are all times 4, meaning A is exponential. And then that times 4 is our b value for a times b to the x. But we need our a value, which is the initial value. So if we go back to the 0 value in the table, we're going to get 1. So the equation is 1 times 4 to the x. In B, we're adding 5 each time, which makes it linear. That adding 5 is the slope because it's the change in y over the change in x, which is just 1 each time. And then going backwards to get the y-intercept at 0, we would subtract 5 and we get 10. Now for C, the y values of h of x, they're increasing by 1. So I'm going to look at the x's and I see they're multiplying by 2's each time, which means it's a logarithmic data. So our equation is log base 2 of x. For D, it's not adding or multiplying by one constant number for the j of x values. But I notice this is +1, +3, +5, +7. And then if we look at the difference between those numbers, it's +2, +2, +2. Because this constant value happened on the second level of finding the differences, it's a quadratic equation. And then for our equation, all those x values squared relate in the j of x values. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So our equation is y equals x squared. Now for e, each y value here is times a half. So again, this is exponential, where the b is 1/2, and they give us the a value right here, it's 400. And lastly, for f, if we look at the pattern, notice that the square root of every x results in the y value. Square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. So for f, it is a radical. Okay, so for 33, it's matching. I'm going to start with graph B because that's the only one with an asymptote not at 0. It's been moved down 3, so that must be graph 3. And then the difference between A and C is an exponential decay because of this 1/4. So that's graph 2. And then graph 1 would be A because it's exponential growth. And 34 to match these graphs. Let's start with D. That's going to have a vertical asymptote at x equals -3 because of the argument. So that has to be graph 1. And then the other logarithm is E. And the only other graph that has the vertical asymptote is graph 5, so that's E. Now for A, B, and C, let's start with C. That asymptote has been moved down 3, and it's an exponential growth. So that would be graph 3. Graph B has a reflection over the x-axis because of the negative coefficient, so that's graph 2, meaning graph 4 then is A.